Each side and every time you see a triple or it's multiple, it's like higher 3 times.
All right. So, good afternoon. I hope everybody is doing well today. I really like this problem a lot because there's so many different possibilities, so many different pathways, and it was a challenge. And I really like that aspect of it. One danger in a question like this, and we're going to start seeing this more and more, is the danger of one person in the room figuring out the answer and then kind of the air being let out of the room because a lot of us hear the answer. So you hear someone say, oh, the answer is, oh, I figured it out. And then you kind of go, oh, the suspense is kind of gone. But what I want you to keep in mind in that situation is that it's not the answer that's the important part at all. I actually toyed with the idea of giving you the answer and just asking you to tell me why. But if I had done that, I would have eliminated several pathways for you because you wouldn't have been able to explore on your own. So I decided against that, but I could have done it. So let's hear from you. What'd you get? Start with Ann, Dalton, Zabari, Sebastian, Brandon, and then Brian. Sure, the answer. X equals 12.
I got X equals 12 because
Don't tell me the because, just tell me your answer to start with. 12, okay? 12. Okay? So many of us already feel that the answer is 12, and as I said, I could have just told you that the answer was 12, and that doesn't really mean anything. And I'll be honest with you, it took me a long time to figure this out, but it piqued my interest because I couldn't understand why I couldn't figure it out. I'm like you guys, I tend to, when things don't make sense to me, sometimes I just feel like I don't want to deal with it. But this one piqued my interest. I couldn't quite figure it out, and then something just kind of clicked. Because I just spent a little time and I looked at it. So what clicked for you? I heard a lot of different things. So we're going to go back to Ann and then we'll go around. Ann, what clicked for you?
I used triples because 15.
Okay. The 15 here.
Yeah.
What did that mean to you?
Well, since it's the hypotenuse, when it triples, the hypotenuse number would be 5, and 15 is multiple of 5, so I automatically thought that would be 3, 4, 5 triangle.
Okay. So you said to yourself, maybe this is a 3, 4, 5. Even though it's hard to gather the evidence that proves it, you supposed it. Okay? But it's a multiple of that. Okay? So if it's a 3, 4, 5 triangle, what would this distance have to be then?
9.
That would have to be 9. And then that would have to be the 12 that we already know. So this would have to be 12. Okay? But then, does that fit the rest?
Yeah.
It does. Okay? So how does it fit the rest?
So another triple was 5, 12, 13, and 13 was the hypotenuse, so the smaller side would have to be 5.
Okay? Because now we have the 12 here, and so it seems like we have 2 out of the 3, so the question is, does this equal 5?
Yeah,
And does it work out?
Yeah, because you add 5, but then that equals the whole.
That's right. So if we take the 5 and the 9, that comes out to 14. And so it's okay if you want to take a guess at something. If you want to say, let me try and see, what if this was a Pythagorean triple? What would have to be true? and then test and see if that works. Okay? So, and I spoke to that group, to your team, and we figured out that that method was called what? It's guess and check, which is a perfectly valid method of solving any problem, not just math problems, but any problem. Guess and check. Take a guess at what you think would be true. Check to make sure it works. That's the key, is gathering the evidence to make sure it works. And she did that by doing that right there. If she had stopped and said, oh, that's a 3, 4, 5, that's 12, I would have to object and say that's not enough. But she took the time to prove it. And this is the part that proves it. Because this then becomes a 5, 12, 13 Pythagorean triple. Okay? So Brandon, I apologize because I know that your thunder was stolen a little bit because you had proposed almost the same idea to me, right? So I apologize for that. And I know you had your hand raised to volunteer. But do you have basically the same idea, same thought process that you went through?
Well, I had I looked for which one of the triples ended in 15.
Okay, so you did a similar idea, but you looked at this and this. And then what was the connection that you saw?
And when I found this triple, I looked for which they had in common. And I found that two of them had 12 in common.
So they both had the 12 in common. And that's when it clicked for you, right? Good. Okay. There were other ideas, so I apologize. Dalton, and then I'll go to the back. And again, I apologize if someone took your thunder. Go.
I just went backwards from what she did. I did 13, 5, and 12 first.
Okay. So you started on this triangle over here, and you saw the connection. You said to yourself, that's a 13. Maybe this is a 5, 12, 13. And then you checked using the other side. Interesting. Very good. Zabari and then Sebastian, and then Davis up at the front. I'm sorry?
I did the same thing.
You did the same thing, okay? Sebastian?
I did the same thing. I have a question.
Yeah.
You just solved the missing number by getting number that adds 14 and using it as a base.
Like just picking combinations of 14 and trying to find the right combination that made it all work? What do you think?
I'm guessing because it's a bit longer, but I'm guessing it worked.
Yeah, I think that would work. I think that would be great. Okay, Davis and then Funk.
When I looked at it, I was thinking, wait a moment. Because at first I missed that it was like one side was shorter than the other with the base. So I thought it was 7, 7. And then I realized, wait a moment. This will take really long to do.
Okay.
So I looked at the 3, like the 5, 4, 3,
Well,
4, 5.
Yeah, let's not call it the three things.
Yeah, I can't remember.
Okay, well, you got the cheat sheet right in front of you, so.
I looked over at her sheet.
Oh, okay. Pythagorean triple you were talking about?
Yes, thank you.
Oh, okay, you're welcome.
And I realized, then I looked back up there and realized once I showed on the other, I was like,
Okay, but then it clicked,
oh,
right?
yes.
Good.
And then I realized, okay, what two numbers what number would make it so that both of those would make Pythagorean triples?
Okay,
And I thought 12 because 15 was really 5 times 3.
right.
And again, 12 to 13 because it was 5, 12, 13.
Okay,
And then I checked it out with those and it matched.
okay, good. Fun?
I did guess and check, but there's a question I want to ask. Like, could you make it into an equation? Because I don't know how to.
Yeah, I actually explored this myself, so I'm going to do that in a moment. But Dalton, you had another thought that you wanted to express?
No, I was just saying before I even did this equation, I want to see if I can find an equation to do this.
Okay. Well, I'm going to start with Daniela and then Ania. Okay. Well, I'll say that you got a little bit lucky because this is not a perpendicular bisector. It's an altitude. A perpendicular bisector would cut these two into equal pieces. And then you're talking about the property of a median. The medians are cut into a ratio of 1/3 to 2/3 when they meet at the centroid. So you're talking about something a little bit different. So I would have to look at what you did. I think maybe you got a little bit lucky, but it's a little hard for me to tell. So let me look at what you did, okay? And then there was somebody else I told. Ania, go ahead.
I pretty much did what Ann did. I checked with the 15 if it's a triple, but I realized that 2 of the columns could have 15. So I checked with 13 and I only had 1 possibility for a triple and then I just checked.
Okay, so you looked through the choices and you kind of whittled it down because once you checked over here, you knew that it had to be the one with the 12 in it. Good, good. And then I'm going to get to yours. Go ahead, Kathleen.
When you came over here, why couldn't you tell me that there was an easier way?
Because your way is the real way.
But it's the hard way and I did it wrong.
Okay. Well, my advice to you in the future is don't do things wrong.
Do it.
I know that's profound advice. But I'll show you in a moment what you could have done. So I'm going to get to the equation. So something we've done in the past, and there were several people who did this, although initially they fumbled a little bit, is in the past we said, okay, we know that this is all together 14, but I need to know that. So let's just call it x. What would this be? If that's x, what would I name this segment over here? This is something we've done before. Jada? So this would have to be 14 minus x if that's x. But now there's a problem. What's the problem? What's the problem with this? Chris?
We already have x as a variable.
Yeah, we already used x to designate this distance. I can't use x to designate another distance because x is the same thing in the entire diagram. So now that leaves me with this. Choose another variable. So now I'll call this, I don't know, z, which would make this 14 minus z. Now, Pythagorean theorem. I mean, we could, if I, just to make it a little easier for you to see, if I got rid of this for a minute, well, I shouldn't have erased that, that was the x, but we could do the Pythagorean theorem with that, right? That would be z squared plus x squared equals 13 squared, right? So, z squared plus x squared equals 13 squared, which is 169. We okay with that? We understand where that came from? So here's where you have to be able to take things that you have learned and start mixing it all together. Can we solve z squared plus x squared equals 169? We can solve it? Can I solve it and find out what x is and what z is? No, we cannot solve it and find out what x and z are. What do we need to do so that I can find x and z?
What I remember, like, we do something like, I think remember called substitution.
Yeah, and what situations did we use substitution? What was that called? And this is something that you should start remembering from today moving forward, right? It's not linear pairs, that's something from this year. Is that what you said, linear pair? Okay, you're probably thinking of the right thing, you just named it wrong. Kathleen? Yeah, it's a system. But in this case, it's not a linear system because linear would be just x and z. This is quadratic. But here's where you need to stretch your mind. So Sebastian, watch. If you want to find 2 variables, you need 2 equations. If you want to find 3 variables, how many equations do you need? 3. Can we write another equation that has an x and a z in it? Can I do the Pythagorean theorem with that? So we can now do the Pythagorean theorem with this, and I can say 14 minus z squared, 14 minus z then squared, sorry about that, plus x squared equals 225. Now I have a system set up. Is it easy? No. Is it something we've done before? No. But the next part is not that hard a stretch. What was the method, Fung, that you referred to from last year?
Substitution.
Right. So if we can get one of these variables isolated, look at this. There's an x squared right here and there's an x squared right here. What if we rewrote this equation so that x squared was by itself? What would it be? If we rewrote this equation so x squared was by itself, what would it be? Alicia?
X squared equals z squared plus 169.
Close. Made one tiny little mistake.
No, negative z squared.
Very good. That is equivalent to this. So now we don't need this anymore. But now watch what we can do. This is now substitution. We can now take this expression and put it in place of the x. And now how many variables do we have in the equation? Just one. Now we can find the z. So is this super easy? Of course not. Is it a challenge? Of course. Does it require perseverance and require some effort? Absolutely. But you already had all the tools available to you to do it. So there is a way to prove this, to prove that x is 12 without doing guess and check. Okay? So I've actually started working through this. I haven't finished it yet, but it actually works out really nicely because the z squareds end up canceling each other out. And it ends up being a really easy equation to solve. So at this moment, the only little hiccup is this right here, and we talked about this just the other day. That's square of a binomial. That's, again, a tool that you learned last year, okay? So there were some thoughts. Sebastian, Brian, Catalina. Sebastian, go.
When you do that equation, are you solving for z or is it
I don't know. What should we be solving for?
x? Is the answer because z is solved?
We're looking for both of them, basically. Doesn't really matter. We're looking, you said it, we're looking for which one, really? We're looking for the x. But to do that, we needed the z to help us along. Whether we end up finding z or not, I don't know, but we got to find x. Okay? Now, the way I did the substitution, by replacing this with this, I end up with all z's. So I will end up solving for z and then finding what x is. That's the way I'm going to do it. Is there another way to do it? Probably.
Yeah.
Okay? Brian and then Catalina, and then we're going to move on.
Never mind.
Okay?
I did it, but instead of solving for x for the substitution, I did it for z, and I just realized that it has to be z squared equals, because I saw that, I thought that I could simplify from 1 for z, so I did the square root of both of them, and I got z equals 13 minus x, and then I plugged that in, but I see that you can't do that.
Yeah, you can't do... Oh, wait. No, you can't do that. Oh, you could do that. Z equals 13 minus x? Yeah, I think you're right. Didn't work? Let me take a look.
It got really ugly, because then you have to, for z you have to put in more parentheses because it was 13 minus x, and then doing the square of that was so hard. Well, it wasn't hard, but it had a lot of work to it, and I think I messed up something.
Okay. I don't know. I think you were onto something there, though. I think your way is easier than mine, but I'll take a look. Okay? No matter what, the important part for you and for others who tried it, and there were a few who tried it, is that you figured out that this was possible. Okay, maybe the end result wasn't there for you, but the fact that you were able to piece together all these different ideas into one question is very impressive. And those of you who did the guess and check and figured out that it was 12 by doing, investigating, and gathering evidence, that was great. Okay? Any other comments, questions on this? Okay, so we're going to... So last time we were together, we began exploring the Pythagorean theorem. We're going to build on that today. Today we're going to look at two things that are kind of all wrapped together eventually. We're going to look at the converse of the Pythagorean theorem, and we're going to also look at something called the Pythagorean inequalities theorem. So you should have your cheat sheet out, and it should already be filled in because you already did the read ahead. But let me clarify our goals today. Our objectives are to use the Pythagorean theorem and its converse to solve some problems, and use Pythagorean inequalities to classify triangles. Okay? No new vocabulary really, but we have a lot of new ideas that we're going to explore. So, from the cheat sheet, the converse. First of all, any time that we have explored a theorem or an idea and then I say we're going to talk about the converse, you already know what's going to happen. Because you already know from way back at the beginning of the year that converse means you flip-flop the hypothesis and the conclusion. So the Pythagorean theorem says that if you have a right triangle, then a squared plus b squared equals c squared. Now flip it around. If a squared plus b squared equals c squared, then it must be a right triangle. That's converse. And that's what we're seeing here. So you see the last statement sums it up. If this is a true statement, then the triangle must be a right triangle. That's the converse. Any questions about that? Now we can expand on that idea, and with one change to this right here, we can actually learn a few other things. And this is actually two different theorems that I wrapped up all into one package. And it's the triangle inequalities theorem. And what it says is that if the square of the hypotenuse is less than the sum of the squares of the legs, then it's going to be an acute triangle. If the square of the hypotenuse is greater than the sum of the squares of the legs, then it's going to be an obtuse triangle. So it's written out here in words, and it's also written out here kind of in a summary statement, in a conditional statement. Two conditional statements, I should say. Now, I was reading through this, and I was learning it for myself and trying to understand, and another idea came up, and I got really confused. So I'm front-loading it. I'm giving it to you right at the beginning as a reminder. The triangle inequality theorem, and I've written it down here, remember. The triangle inequality theorem is something we learned a while ago. And it says that the sum of the lengths of any two sides of a triangle must be greater than the third side. Otherwise, it's not a triangle. That sounds confusing with Pythagorean inequalities theorem. This theorem, the triangle inequalities theorem, will tell us if three lengths will be a triangle at all. This theorem, the Pythagorean inequalities theorem, tells us what type of triangle it will be. This tells us if it's a triangle. This tells us what type of triangle. Now, if you take all of three of these ideas together, we can figure out if three lengths will make a triangle, and from there, if it's true, figure out whether it's a right triangle, acute, or obtuse, just based on the lengths of its sides. And that's what we're going to explore today. Does anyone have any comments or questions? Good, let's jump in and get to work. So, first, let's work on verifying whether or not triangles are right triangles or not. So we're focusing on the first idea of the converse. So there is no indicator here that this is a right triangle, which means that we don't know if it is. But it looks like it could be. It looks like that might be true. But it's not a guessing game. So we have to prove it. And so we can use the converse of the Pythagorean theorem. If a squared plus b squared is equal to c squared, then we can say that it's a right triangle. So that's the evidence that we need to gather. So let's go ahead and do it. 9 squared plus 15 squared, does that equal, so we're asking, does that equal 3 radical 34 squared? If it does equal, then we say yes, it's a right triangle. If it doesn't, then it's not. So, now it's mental math and calculator issue maybe? So I already know that. I already know that. Wow, Mr. Gallo, I'm very impressed. That, I don't know if I could do that mentally. Maybe I could. How do you do that? How do you square 3 radical 34? How do you do that, Davis?
I forgot where I heard this, but I do believe that if you try to square anything that's radical, it just becomes itself.
Okay. You don't know where you heard that?
I think I heard it from you, somewhere from.
It's possible.
And you just multiply 34 with 3 squared, which is not.
That was pretty good. This actually comes down to a property that I'm teaching the current algebra students. It's up there on my wall of properties. It's the power of a product property. And I last year said that it was kind of like the distributive property, although it's not. And what it says is if you have a product brought to a power, that each factor gets brought to the power. And so Davis was spot on. 3 squared is 9. Radical 34 squared, when you take a square of a radical, you're basically undoing it, so you get 34. So now, calculator. What do we get on the left and what do we get on the right? Oh, and by the way, we're still asking, is this a true statement? So what do we get on the left? Anyone got it? Alicia, what is it? 306. Does that equal 9 times 34? Does it?
Yes.
9 times 34 comes out to 306. So now we have the proof that this is a right triangle, and so we can very simply just say yes. This is a right triangle. I have proven it by using the converse of the Pythagorean theorem. Anyone have any concerns, questions, thoughts, theories, anything at all? Go.
So you're trying to see if the triangle is a right triangle, and you prove it that it is, but the triangle looks slightly nothing like a right triangle. Will that ever happen?
I guess it's possible. I mean, it wouldn't be. I would be frustrated if I would never give you a question like that, but I would be frustrated if you saw a question that looked totally not like a right triangle. I mean, if you got this, and then someone put 3, 4, 5, I would be frustrated because that would mean that's a right triangle, but it clearly is not. So, usually you'll see a disclaimer in diagrams that say, diagram not drawn to scale or something like that. But usually it's, close. Okay? But that's a good question. Any other thoughts or comments? Any questions, concerns? Good. So let's make sure we've got a good understanding. What about part B? What if we did this? Is that a Pythagorean triple? Because if it was, wouldn't that prove it right away? Is that a Pythagorean triple? Is it a multiple of a Pythagorean triple? It's not? We divide them all by 2, that's 7, 11, 13. There's no Pythagorean triple, 7, 11, 13? So I guess we have to do the converse of the Pythagorean theorem. Yes, Chris?
Figuring out if it's a right triangle or not, can we just multiply the rightmost digit of each? Can we square the rightmost digit of each number? Like rightmost digit of a squared plus rightmost digit of b
Try it.
squared?
I don't know.
I mean, that won't give you the squares, but it would tell you if they're
Try it and see if it works. My thought is that that wouldn't work every time, but I want you to try it. See if it works.
because the Pythagorean theorem and the Pythagorean converse basically squaring them, but if they turn out to the same.
But I want you to actually take this example, and I want you to test your theory. Did you already did?
Yeah.
Okay, now test it on that one.
Could you kind of just see, like both of them are like way over 26 squared, and then make it like not true?
Well, I think you're overestimating your ability to estimate squares. Let's see how it plays out, and you'll see my point. So now, unfortunately, it's not a Pythagorean triple. So now we need to do 14 squared plus 22 squared. And we're asking, does that equal 26 squared? I know some of this off the top of my head, but not all of it. 14 squared is 196. What's 22 squared? Anyone got it already? What is it? 484. Anyone got 26 squared? 676. So, what does the left add up to? 680. So Dalton, your thought about, is it easy to tell because it's so much more? Is it so much more? No, it's actually incredibly close, but clearly it is not a right triangle. So we would say no. Okay? Any comments, questions, or concerns about this? Okay, so let's see how we do on our own. Checkpoint number 1. I want you to tell me whether these lengths, these sets of lengths, constitute a right triangle. So you got 3 minutes for 2 questions. All right, so let's do this by survey. Part A, give me a thumbs up if you think that that will form a right triangle. Some people, looks like a majority say yes, some people say no. Yes, this will form a right triangle. And part B. Give me a thumbs up if that will form a right triangle. Doesn't seem like anyone thinks it will, and it will not. Any questions or concerns about how to use the converse to determine whether or not a triangle is a right triangle? Any concerns? Any thoughts? So now we're going to build from there. We're going to basically do a lot of the same things, still looking for similar ideas, but now including the idea of the Pythagorean inequalities theorem. So, example 2. One question, but it actually has 2 parts. Can segments with the lengths 4.3, 5.2, and 6.1 form a triangle? If it will form a triangle, is the triangle acute, obtuse, or right? So the first question is asking, will it form a triangle at all? So this is where my little reminder comes into play. Not the Pythagorean inequalities theorem, the triangle inequalities theorem will help you determine whether or not lengths could make a triangle. In other words, is it possible to have 3 lengths that don't form a triangle? Will those 3 lengths ever form a triangle however I arrange them? If I took this length and put it over here, or this length and switched it over there, there's no way to arrange those 3 lengths. So not all 3 numbers will make a triangle. So the question is, will these make a triangle? And here's where we use the triangle inequalities theorem. We take any 2 sides of the triangle, and the sum must be greater than the 3rd side. So we start out with 4.3 plus 5.2, and we need to ask ourselves, is that greater than 6.1? Is that true? Yeah, it's easy to see because you could just estimate. 4 or 5 is 9, that's clearly greater. Now, technically, you're supposed to test the other 2 combinations, but the other 2 actually will always be greater than if it's going to form a triangle. So if I start out with the 5.2 and add the 6.1 and ask myself, is that greater than 4.3? Well, of course it is. This number by itself is greater than that number, so of course. And then same thing, if I do 6.1 plus 4.3, is that greater than 5.2? Of course it is, because 6.1 by itself is greater than 5.2. So really the only statement that really needs to be verified is that one.
So whenever you get a question like this, all you can do is add the least, like the side that has.
I'm not sure if you only have to do the least, but I think that might be true. I would have to do a little more experimenting, but I think you're right. I think that was pretty much what we have to do. But what we have shown by proving all these statements true is that yes, this will form a triangle. It will. But now the second question, what type of triangle will it form? Will it be acute, right, or obtuse? We don't have a picture, so I could draw one, but that would mean I need a ruler and I need to measure everything out. So we can do it by understanding that this is the smallest side because it's the smallest number. That must be A, that must be B, and that must be C. Now, instead of doing the Pythagorean theorem, we're going to find A squared plus B squared, then we're going to find C squared, and then make it a true statement. So again, A squared plus B squared we're going to do over here. C squared we're going to do over here. We're going to reserve what symbol is going to go in between till the end. So now it's a lot of calculator work. We've got 4.3 squared plus 5.2 squared, and we need to do 6.1 squared. 4.3 squared is 18.49. And then 5.2 squared is 27.04. And then the other side was c squared was 6.1 squared. We get 37.21. And so now the question is, what symbol would go right here to make this a true statement? What symbol would go in between to make it a true statement? Caleb? Yeah, you can easily see. This is like a 37. That's 27. That's much more than 10, so that's clearly going to be greater than. So now we've made it a true statement, but now we need to interpret the statement. So now look back at your cheat sheet at the Pythagorean inequalities. Go ahead, yes and then yes.
Looking back, it would be
Obtuse? What were you going to say? So you say it's acute and you say it's obtuse. Okay. Can we all agree that it's not a right triangle?
Yes.
Because they would have to be equal, right? So now we're kind of up in the air. What do you think, Michaela? Acute. So to figure it out, you want to focus on the c squared. So you're focused here. If that is smaller than the sum, then it's going to be acute. If that is greater than the sum, then it's going to be obtuse. So I think Maria was looking in the right place, but she was looking at the wrong piece of information. She was looking over here. So this is going to be acute. Maria, do you see it now?
Yeah, I was
Oh.
right before.
Okay. No, because you wouldn't be able to tell. There's going to be cases where that won't match this. I understand that this came out to be the same symbol as this, but that won't always be the case. So you have to do the Pythagorean testing to figure it out, okay? Good. Any comments or questions? Other comments and questions? All right, so let's see how you do on your own. I'm giving you two. First, decide if it will form a triangle. And once you figure that out, if it will form a triangle, will it be acute, right, or obtuse? So a little bit more involved in these. So I'll put 4 minutes on the clock. If you have time left and you're done and your teammates are done, by all means, compare your answers and see how you did.
15?
All right, let's survey first. Part A, give me a thumbs up if that will form a triangle. A lot of dramatic thumbs up and several clear dissenters. Put your thumbs down. Yes, it will form a triangle. And part B, I'm going to jump to part B. Give me a thumbs up if part B will form a triangle. Some of us say yes, some of us say no. Put your thumbs down. It will form a triangle. So now, part A. What type of triangle do you say that that will form? I've got students 16 and 5. Student number 16, what do you say? I'm sorry? Okay, student number 5, what do you say? Do you both think it's acute? It is acute. And part B, what type of triangle will that form? I've got students 17 and 15. Student number 17. And student number 15. You both think it's obtuse, and it is obtuse. Anyone have any questions, concerns, any theories, any observations? Go ahead.
For part A, I didn't understand how you would do, like, I know how you would, like, for the 3 1 to 17, I know how you would, like, put it in its original form, but I didn't, like, this question just confused me.
Okay, I'll come work with you in a moment. Okay, any other concerns? Okay, so we're going to do something a little bit differently now. So example 3 is actually not, it's an example and it's important, but I'm going to treat it as something different. We're going to do a mini lab, and I need you to first read the description and look at the picture and do your best to understand. I'll be available for questions about it in 1 minute. Go. Read to yourself.
I was trying to pronounce.
Okay. So, any questions about the terminology? Yes, Davis.
What is a catamaran?
A catamaran is a type of boat. It's a little hard to tell from the picture, but this here and this here are two, I don't know what they're called, like runners. They're two parallel floating buoyant devices. And then there's a big giant piece of cloth, or maybe it's a hard piece of some material between them, and people can basically sit right on top of there and it will float on the water. But some of them are set up like sailboats that have masts. The mast is the long pole that comes out of it here, and that holds the sail that allows the wind to move the boat. So a catamaran is a type of boat. The mast on a boat must be perfectly perpendicular to the base, to the trampoline deck or the deck. So how can you check that the mast is perpendicular? Using a tape measure. So that's the question, but I'm going to customize it a little bit into a little lab. So everyone has a blank sheet of paper, and I know there's a few of you who don't have the pencil, but if you take the piece of paper and the pencil, for the lab, the piece of paper is going to be the catamaran, and the pencil is the mast. You have a few things that you may use. You may use the piece of paper, the pencil, you may use your ruler, and you may use your sharpened pencil, and that's it. You can use your calculator as well, but you probably, well, you might need to. So you can use your calculator as well, I'm sorry. So your job with your team is to figure out how you could prove, how you can make sure that the mast was perfectly perpendicular to the deck. And it's not a guessing game, and it's not you walking up to me going, look, Mr. Gallup, I did it. That's not what I'm looking for. I'm looking for how could you prove it, and then if it fell down or if it was sitting on the desk, how could I pick it up and then redo it? So it has to be something that you can duplicate over and over again. Okay? Other than that, I'm not telling you a thing. Any questions? Brandon? You can write on the paper, you can write on the pencil, you can put marks wherever you want. Any questions? You can use only the paper that I gave you. I'm coming around with the materials that a few of you didn't get. You've got about 12 minutes of time to work on the lab with your team. Probably not enough time to work it out, but maybe it will be. Go. You do not have unsharpened pencil? Why did you guys not have unsharpened pencils? I pass that over to Tom and make sure she doesn't sharpen it. You. No, I didn't say in the middle. I said it has to be perpendicular. I don't care if it's perpendicular over here, or perpendicular over here, or over here. But it needs to be like that. This is the depth. It's perfectly perpendicular. So I don't care if it's like this, but it still has to be perpendicular. Okay, so I intended more time for this, and this was not enough time for you. I'm sorry, we're coming back as a whole group. This was not enough time for you to really work through the lab. But you definitely made some good progress. I was pleased to hear a lot of your ideas. So there was kind of a recurring theme between a lot of the teams. So could someone articulate, a basic idea that you were trying to use? Ania, and then we'll go to Alicia.
You measure the height of the mast and measure the distance from the mast base to the edge of the ship and find the hypotenuse.
Okay.
And then using the Pythagorean theorem to find if it's a
Okay. So the overall theme that you're referring to is perpendicular and right triangle have a relationship, right? Because if it's a right triangle, that means that the longer side, the longer leg is going to be perpendicular to the shorter leg. Okay? Okay? So I had set up a little diagram for me to play with, and so this was the pencil, and a lot of you tried to take that pencil, and a lot of you put it right in the middle, and then a lot of you drew this distance from here, maybe this way, out to here, and then tried to figure out, okay, well, if I draw that, then this would have to be a certain distance. If that distance was achieved, then that would be a right angle. So in other words, what you're trying to do is, if the mast is tilted a little bit like that, then this distance would get longer and therefore would not be a right angle. If it was tilted the other way and tilted more this way, this would become shorter and therefore it wouldn't be a right angle because that's the Pythagorean inequalities theorem. So if we can pick a distance here and make sure that the distance happens, then it will be a right angle. But the issue was a couple of things. One, a lot of you came up with a method that works only on your individual piece of paper and with only your pencil. I want a method that can transfer from one to the other very easily. So we need some more friendliness to it. And then there was another issue that I'm not going to outline right now. So you guys are on the path, and we're going to explore this more, but I need to wrap up. So your homework is on page 438, numbers 9 through 23, and then in bold you see the questions that really require the effort. 33, 34, 36. 37 you're doing only A and B, and these count as 2 separate points. 40 counts as 7 points, but it's not like it's 7 crazy questions. It's 7 little things that you need to fill in. So I'm counting it as 7 points, and that makes it easier to get a good grade. Read the next section and fill in the cheat sheet, or do the at-home tutor and do the cheat sheet, and then you'll have a quiz next week.